this video, we're going to use Khan Academy to practice writing explicit formulas for arithmetic sequences. Now, an explicit formula is a formula that helps us figure out a specific term in a sequence of numbers. For instance, if we want to know what the 17th term is, we would plug in the number 17 into our formula. Or if we want to know what the first term is, we would plug in the number 1 into our formula, and it would tell us the first term. Now, an arithmetic sequence is a sequence where we are adding the same number repeatedly each time. So let's take a look at the sequence here. So we're wondering, what number are we adding each time? And we have a pretty good clue here that we are subtracting 27 each time, or adding negative 27, because 27 minus 27 equals 0. And we already know this is an arithmetic sequence because they told us. So we are subtracting 27 each time. Now we can figure out that common difference using a calculator also if we can't figure it out by inspection. So let's practice doing that. We can pick a number in the sequence like 54 and subtract the number that came right before it. So 54 minus 81. And there's our common difference, negative 27. Let's practice that one more time. Let's say we start with 27. We'll subtract the term that came right before it, so minus 54. And we get our common difference, negative 27. Okay, so we have our common difference. Now we're trying to write our explicit formula for our sequence. I prefer to write my sequences a little bit differently. They have kind of like this function notation here. I prefer to write a sub n, where n is the term number we want. So I would write this as a sub 1, the first term. By the way, they're noting here that the first term should be term number 1, because some people start with term number 0, but they're saying it. Don't do that. The first term should be term number 1. Okay, to write our explicit formula, we're going to start with this rate of change here, or this common difference, and multiply it by the term number. Now, this isn't correct yet because notice if we plug in the number 1, negative 27 times 1 does not equal 81. So we need to make an adjustment here. To find out that adjustment, let's see, we'll be adding something here. We can imagine what the term right before 81 would be. Let's see, so we have some number, minus 27 equals 81. So to figure that out, well, we could actually work backwards and add 27 to 81 to figure out what would go here. So that would be, see, 81 plus 27, that would be 108. Now, this is not a number in the sequence. We're just trying to figure out what adjustment to do here. So we have 108 minus 27 equals 81. So we have a sub n equals negative 27 times n plus 108. Now let's check it. Let's see, when we plug in 3, we should get 27. So let's see, negative 27 times 3 plus 108. Yeah, and we get our third term. So I plugged in the number 3 into our formula, and we got our third term. It looks like it's working. Now keep in mind, this 108 is not actually a number in the sequence. We're just using it to help figure out what this adjustment is, because when we plug in the number 1, well, we haven't subtracted 27 yet. But negative 27 times 1 would mean we are subtracting negative 27. So we're not starting at 81 in our formula, we're starting at 108 because we've already subtracted 27 once. Okay, this question is set up a little bit differently. Carlos and Anna were asked to find an explicit formula for the sequence negative 10, negative 4, 2, 8, and so on, where the first term should be f sub 1. So we want the first term to be term number 1. That's all they're saying here. Carlos said the formula is this. Anna said the formula is this. So these look a little different. Now, they could both be right, neither could be right, or one of them could be right. Why don't we figure out our own formula first, and then we'll look at theirs. All right, the first step is to find the common difference. Looks like we're adding 6 here. And we can see that very clearly from 2 to 8, we are adding 6. So the common difference is 6. All right, so in our function, or pardon me, in our sequence, we're going to start with that common difference and multiply by n. So if we plug in 1, 6 times 1 is 6. That's not our starting value, so we need to make an adjustment here. So we're going to imagine for a moment that there's an imaginary 0 term here. So we need some number that we add 6 to get negative 10. Well, we could kind of undo this and subtract 6. So that'd be negative 16. So if we had an imaginary negative 16 here, we would add 6 to it to get negative 10. Now, that term isn't there, it's just imaginary. So we have 6 times the term number minus 16. Let's check it. If we plug in the number 3, we should get the third term, which is positive 2. Well, 6 times 3 is 18, and 18 minus 16 is 2. So our formula does work. All right, notice that this formula doesn't look like either one of these, but these are written a little bit differently, although we already know that Carlos is wrong, because we could rewrite his as 6n minus 10. But we know the correct formula is 6n minus 16, so Carlos is wrong. Let's go ahead and simplify this one. We have negative 10 plus, let's distribute the 6, that'd be 6n minus 6. Combine the like terms, negative 10 minus 6 is negative 16. So Anna said 6n minus 16, which is what we got. So in this case, Anna's formula is correct and Carlos is wrong. Right here we're writing an explicit formula for this arithmetic sequence. First step, find the common difference. So we're trying to figure out what number we're adding each time. Well, it's getting more negative, so we're subtracting some number or adding a negative number. And it looks like we are subtracting 12. We can double check that here. So you take any number in the sequence here, any term, like negative 14, and subtract the number that came right before it. So minus negative 2. And we get our common difference of negative 12. So we're subtracting 12 each time. That common difference will help us write our explicit formula. So we have d sub n. I like writing subscripts instead of this function notation here. That'll be our common difference times the term number. But we can't leave it like that, because when we plug in 1, we don't get negative 2, we get negative 12. So we need to make an adjustment here. An easy way to think about that is to imagine what the imaginary term before negative 2 would be. So to figure that out, we'll just work backwards and add 12 to negative 2. So negative 2 plus 12, well, that equals positive 10. So if there was a term right before the negative 2, it would be the 10, because 10 minus 12 is negative 2. That just kind of makes an adjustment here so that for the first term, we end up with negative 2. I always like to check the third term. So negative 12 times 3 is negative 36, plus 10 does equal negative 26. All right, so we have our formula, negative 12n plus 10. Okay, once again, we have two people writing formulas. Now, in this case, there's no way both of them can be correct, because they have the same minus 8n, but then different starting numbers here. Well, let's go ahead and figure this out here. So we're looking for a common difference. As we move to the right, it becomes easy to see that we're subtracting 8 each time. Let's see, let's get our sequence started here. So I have f sub n equals -8 times the term number. Now we need to make our adjustment here because -8 times 1 does not equal 24. So we're working backwards here to figure out what the imaginary term right before 24 is. So let's go ahead and add 8 to 24. Let's see, 24 plus 8 equals 32. So 32 minus 8 equals 24. So that's our adjustment, plus 32. So -8 times 1 plus 32 does equal 24. I'm going to get rid of that 32 over here, though, because that's really not a number in our sequence. And let's check it with the third term, just to make sure it really works. -8 times 3 is -24, plus 32 does equal 8, which is the third term. Now, looking at the two formulas that Felipe and Ling wrote, we notice that Felipe, in fact, has the correct formula. His is just written in a different order. Hopefully these examples about writing explicit formulas for arithmetic sequences have been helpful. My name is Mr. Ela, signing off.